Okay. Can you see my screen that says Intro to Python class? Oh, right. Okay, so this is me. Okay. Senior level software developer, also someone who cannot keep track of time zones. I'm a US military veteran. I was in the Navy, operated nuclear reactors, did electronics, and a bunch of nerdy stuff. And that's also where I discovered that I like teaching. I got volunteered for it one day. My boss said, "Hey, we have a new class of trainees starting tomorrow, and you're going to teach them electronics and nuclear power." And I about had a heart attack. And they put me in front of 20 new students and gave me a lesson plan and said, "Have fun." And it turns out I love it. I just that aha moment when people learn something new is just magical to me. I'm also the co-founder of the Tech Academy, the school that puts on these free classes. So that's me. Although that picture, frankly, um, I think it's about 10 years old, and I've got a little more gray in my hair. So, um, basic class rules, what to expect. We have a class assistant you'll see here in chat, right? And she's there to answer questions, make sure everybody's nice. So please be nice to each other and to everybody else. I want to stress that we're going to do some coding tonight, and I've done everything I can to make it so it's easy, confrontable, and you can get through it. But I do want to preface that by saying that you are going to be challenged anytime you learn something new. It's going to be a bit of a challenge, right? But stick with me, and you'll learn a lot of cool stuff. One big sort of thing to keep in mind is when we get to the point where we're writing actual computer code, we're writing a program, I'm going to go slow, and I want to make sure that you write the code exactly as I've written it. And the reason for that is computers are stupid, but they can't think, right? Despite all the articles about artificial intelligence you're seeing in the news today, computers can't think. And so they can't figure out what you meant to say. They can only go off of what you said. And so when you're writing code, something as simple as a punctuation mark in the wrong place, a comma that shouldn't be there, a word that's capitalized that shouldn't be capitalized, all these things can stop your computer program from running. And so when I'm writing code, again, I'll go slowly, just write it exactly the way I write it. Okay. And one of the last things is that try to make sure you're in a distraction free setting. There's a lot to pay attention to here, a lot of really cool things that you can learn. But if you've got a bunch of noise and commotion going on around you, that can make it sort of challenging to do. Now, I know that you know how to use chat. I've seen a bit of it already, but I want to pull up chat, and I'd like you to do me a favor, drop into chat and let me know um, where you're joining us from. Drop that into the chat. Stanford, Florida. Cool. Houston, Texas, Washington, Brooklyn. All right. Tucson. Excellent. So I need to say something really cool about we have someone, Kaim, who's joining us from Brooklyn, New York. Um, I've been to 44 states in America. And one of the states I hadn't been to till about 3 weeks ago was New York. And I finally got to go to New York. I fell in love with that city. Place is amazing. It's absolutely fantastic. So really glad to see someone here from New York. And we've got Newark, Java, Indonesia. Wow, I've been to Indonesia. That's wonderful. Two people from Indonesia. Okay, so we have a truly international audience today, which is really exciting. I love seeing that, right? I'm going to try to watch chat as I go through the class. However, I'm operating with one monitor today where I usually have two. And so it's going to be kind of easy for me to miss chat. So um, this is for my co-host, Gracie. Gracie, if there's a really important question inside of chat and I don't seem to be getting to it, then just unmute yourself and let me know that I should check chat. That'll be really, really helpful. All right. Where did my Zoom control, where did my cursor go? There we go. Okay. So here's the basic agenda. We'll have a short introduction to the Tech Academy, who and what we are, what we do. And then we'll spend a good amount of time writing code and learning some really cool fundamentals, like some of the most important principles about how to program computers. Um, like I said, I try to answer questions as we go through, but we'll have a Q&A right at the end of the code writing just to make sure I haven't missed anything. And then we'll go over some data about our coding boot camps. We help people break into the technology industry. That's what we're all about. Okay. So we'll explain how we do that in case that's something of interest to you. And there is a free gift waiting for you at the end. It's actually really valuable. I think you'll enjoy it. So please stick around till the end. So who are we? What's the Tech Academy all about? Well, we run coding boot camps. And most people at this point are familiar with coding boot camps. I got to tell you, when we started, like I think it was the spring of 2013 that I first heard about them. They were brand new. They'd only been developed like 6 months before, and they were a whole new idea. But now they're really established. And what it is, a coding bootcamp is just a very intensive, relatively short, like 3 to 6 months program to help people break into tech. And typically they focus on practical skills that are in demand in the industry. And at the Tech Academy, we've been offering really, self-paced, effective, highly rated coding boot camps for over a decade now. In fact, I think we're at 11 years. We just passed our 11-year anniversary, right? Our programs focus on really in-demand skills, the skills that employers want. You'll see a lot of that later on as we go through some of the details, right? And the average boot camp in America costs around $13,000 or $14,000. Our programs are priced under the national average. In fact, we have boot camps that start as low as $59.80. And finally, I'm going to read the mission statement of our school, which I'm going to do from memory because I don't have it in front of me. The mission statement of the Tech Academy is to graduate entry-level technology professionals who excel in the basics of the field and go on to have successful careers in technology, and who raise industry standards by virtue of the work they do. That's what we're here for. We're like, our product is you working in tech. That's what we're all about. All right, so let's cover a few fundamental terms before we get into the actual coding. The first one is just, what's a program? Well, it's just a series of written instructions. You get to write them. You get to be in control of the computer. And these instructions, they make the computer perform specific actions. And we're going to do some of that tonight, okay? You write these instructions in a specialized language called a programming language. And it's just like any language. It's a set of words and phrases and symbols, but they're very precise and they mean something to the computer. They allow you to communicate with the computer and tell the computer what to do. This is what we use to write computer programs. The action of doing this, the action of entering those computer instructions in, is called coding, right? Code is the actual written instructions that you made, and coding is entering those instructions. So basic fundamentals. Now, we do need to talk about Python because that is the programming language that we're going to use tonight, okay? And it's a really popular programming language. It's been around for about 35 years now, right? And what's really nice about it is, one, it's relatively easy to use because the way it's written really resembles English. Like, you can read through it and most of the time get an understanding of what it's supposed to do. It's pretty easily understandable. And it's also really versatile. You can create all kinds of applications, websites, games. You can use Python to do a lot of different things in the computing world. So it's a really valuable language to learn. All right. Now, we're going to start with, and I'm going to pause here for a moment because I want everyone to pay attention. Probably the
Erik,
most, yeah.
there is a question. Thank you.
Yep, absolutely. Yep, let me grab chat. All right, cool. So let me address two things from chat. On these free classes, the chat only goes back and forth between the administrators and the individuals. We don't have a free and open chat with all of the class. Okay, just to address that. We do have other classes that I deliver that are much more in depth, where there's open voice, open chat, open video. Right. We very often have 50 people in some of these classes, and so managing a big giant chat like that is pretty not that workable. Othman is asking questions about the mobile app development program and how much it costs. I don't have the pricing in front of me. At the end, we're going to provide links to be able to go in into the site, see all the different pricing, all that kind of stuff. I don't know how much mobile app is, and also there's part-time options and full-time options. There's a bunch of stuff, but we'll give you all the links to be able to get that information at the end. That was a great question, Osman. Let me see if there's anything else I missed inside there. Okay, good, awesome. Okay, so the data we're going to talk about on this slide is the most important data of the night. Yes, we're going to have a lot of fun and learn a lot of things while we're writing code, but there's no more important information that I can share with you than what we're going to cover on this slide. And that's because knowing the 5 elements of a computer program gives you a mental framework to study any computer programming language. And in fact, it can stabilize any sort of anxiety or worry you might have about whether or not you can learn to code. The 5 things we're going to cover here, when you look in any computer program, no matter how small or how big, these are the only things that are in that program. So it's really important. So the first element of any computer program is an entrance point, the first instruction. You can think of a program as almost a recipe. You start at the very first thing to do, and you don't go on until you've done that thing. Then you move on to the second, and then to the third. It's the best way to think of a program. Every program has to have a first instruction. But here's why that's kind of cool, why it's important. The first one has to do with what happens inside your computer when you start a program. I mean, all of us, thousands of times, have logged into our computers and started a program, whether it's a game we're playing, or we start up our browser like Chrome so you can surf the web, or we start a game, a word processing program like Microsoft Word or whatever. You've started programs over and over again. What happens inside your computer when you start a program is actually a pretty important thing to think about and to learn about. Any program, while it's running, is working with a lot of data. And that data needs to be stored somewhere in your program. Think, for example, of writing a document. You're using Microsoft Word or whatever, and you're writing a document, right? Well, the information in the document has to be stored somewhere in your computer. And it's stored in these little teeny devices called memory storage devices. They're actually physical objects. Many of you have probably seen them. We call them RAM. It stands for random access memory. And it's just a little device 3 or 4 inches long with a bunch of electronics on it. But what it does is really cool. Think of these memory storage devices as millions of tiny little locations where you can store individual pieces of information, a word, a number, that sort of thing. Without these devices, your computer isn't very valuable. Your computer needs to be able to store information the program will work with. So why do we care about that? And how does this relate to the first instruction, the entrance point to a program? Well, it's this. There's only so much memory in your computer. There's only so much, room to store information. And when you start up a program, Microsoft Word or a game, again, whatever, you need to reserve a certain amount of that storage space that's only dedicated for use by your program that you're running. And you do that so that no other program that's running on your computer can step in and start to use the same locations for storing data and mess it up. It's a pretty important thing that happens under the hood. So that's an important thing about the entrance point to a program. But honestly, folks, that happens under the hood. You don't really see that happen. It's good to know that it's happening. Okay. The second reason this entrance point is really valuable that does relate to you and what your job might be like if you go into technology is this. Knowing that there is, in fact, a very first instruction to any program, no matter how small or how large, is really helpful to you when you are assigned to work on a large program. Picture this. You finally broke into tech, you've got your first job, you're super excited and super nervous and all kinds of emotions. And you join a part of a team, or you join a team, and that team is responsible for maintaining this already existing really large program. And one of the first things you're going to have to do is get familiar with the program and what does it do and how does it work. It can be a really daunting task. But if you know that there is, in fact, in that program somewhere, the very first instruction, and if you can find it, then it makes understanding that program much easier because you can start looking through the program's instructions the same way the computer does. You can look at what's the very first thing we do as soon as you turn that program on. And what's the second thing? And the third thing? You're following along with the same sequence the computer itself does when it runs the program. And it really helps you to understand that program. So that's the first of these 5 elements. There is an entrance point. There's a first instruction, and it's very helpful to know that and to find it when you're studying a program. The second of these 5 elements of a computer program is what are called variables. And this is just data that's going to change while the program is running. It's so helpful to keep track of this. Let's say, for example, you're playing a video game and you have a score in the video game, right? Obviously, that's information that's going to change. That's data that's going to change as you play the game, right? You have to have a way in your program to keep track of that data. That's all variables are about. If your program didn't have any variables and couldn't keep track of data that was changing, your program wouldn't be very helpful to people. So that's a vital element of a program is variables. The third element to think with is what's called control and branching instructions. These are the way you make a computer program make decisions. This is so valuable. We write programs to help us as human beings to accomplish work that we would otherwise be doing manually. And in our jobs and in our personal lives, we make decisions all the time. If this, then that. That's what a control and branching instruction is for a computer program. How do we tell the program to decide which one of 2 or more possible courses of actions it should take? And if you don't have that in a computer program, your program isn't going to be very valuable. So we consider this control and branching one of the 5 fundamental elements of any computer program. Then let's move on to the fourth one, which is what's called subprograms, and these are awesome. You see the basic description there, a program within a program, but here's really what we're talking about. Let's say you have a really, really long program. Let's say it's got like 10,000 instructions. It just starts at the beginning and it does a lot of things one after the other, right? Well, what you'll find is that very often inside that huge collection of instructions, one after the other, you'll find that there are certain steps that you do over and over and over again. There might be a series of 5 different steps, for example, that are repeated over and over again as the program runs. Let's, for example, think of a computer game, right? One of the things that might happen over and over again with a game is that someone might click on a settings button and it would pop up all of the settings that they have, right? Well, instead of writing in the program that every 5 or 10 minutes or whatever, the settings will pop up to show people what they are, you only want it so that when someone wants that exact thing to happen, they just click on the button and then it happens. So you'd create a tiny little mini program that all it does is display the settings, and that's it. And that way, every time in the program you need that to happen, you don't have to write those same instructions over and over again. You wrote them once. That's called a subprogram, and they're really, really, really powerful, really valuable, and they're a vital part of any program. And finally, we come to the last element of a computer program, which is an exit point. There needs to be a final instruction, an instruction that basically tells the computer, hey, this program that's been running, it's over. It turned off. And one of the main reasons that's important is because now your computer, which has reserved a lot of that storage space we talked about before in those memory devices, it can free up that memory storage area for other programs to use again. And if you don't do that, if you leave that memory storage area blocked off, it restricts the ability of your computer to do a lot of work because it's got a bunch of data area that it can't use. So these are the 5 elements of any program. And as you're going to see tonight, when we write code, There's nothing else that goes inside a computer program besides these 5 things. And so I hope that helps. Okay. Now, let's get to writing some code. You need a place to write your instructions. And to make these classes easier, we provide an editor, a place to write the instructions that's online. Now, into chat, I'm going to drop this link. Okay. I'm actually going to grab this link myself. So hold on a second. Let me copy that. And I'm going to open this up and I'm going to show you what it looks like. So this is what the code editor looks like. You all should have this opened. Now, this part's important. Let me go back to my slide. And let me show you something really cool. Okay. I want you to have my presentation, my screen, side by side with your screen. Okay. And so the way to do that, if you've got 2 monitors, it's nice and easy. You just have the Zoom application on one monitor, which shows my screen. And then you have the browser with this code editor on the other monitor. But if you don't have that, then you need to set them up side by side on the same screen. For a little bit of help to do that, if you are having trouble resizing the Zoom application, you can sometimes click on the word that says Zoom meeting, and then there's a restore button. When you click on that, it can collapse the Zoom meeting a little bit, and you can resize it and move it around. The same thing exists on your browser. On the top right, there's this little symbol right here that looks like 2 squares. You can use that to resize your browser. So I'm going to give everybody a minute to get Zoom on the one side and the browser with your code editor on the right. And then we're going to start doing coding. Okay. Now, the first thing, let me stop sharing for a second and I'll get some things set up and then I'll share again. First thing I'm going to do is show you the program we're going to use as a little bit of context. Uh, Now let me share my screen again. All right, so don't worry about all this code that's in here. In fact, you're going to delete all of this. Now, what I'm going to show you right now is the actual program that we're going to use as sort of a context for our class tonight. You're going to get you're going to get this code later on. We're going to examine it in some detail. But for right now, I just want to run this game. And we're going to play the game Hangman. I'm trying to guess a word here, right? So I'm going to try E. Okay. T. Nope, it's not in there. How about S? Nope. R. Nope. Wow. I'm losing here. M. Oh, I got an M. So an R and an M. Oh, I think I know what this word is. Let me get P. A. O. Yep. G. A. I think I figured out that it's programming. Hey, congratulations, you guessed the word. So that's the game. Okay. And again, you're going to get all that code. But for now, I want everybody to erase all of their code here. And let me see if I can make this a little bit larger. Control plus. And we're all going to start writing some code here. So the first thing is I just want to make an instruction that'll print something off to the right here. Okay. So we use a command in Python that's called print, Print. So follow along and type all this in and do a parentheses. And notice it will create a matching closed parentheses for you. And we'll talk about that in a moment. Then do double quotes. The double quote is just to the left of the return key usually. You have to do shift and do double quotes. And then put hi there. That'll work. And go to the end there and do a semicolon. And we'll talk about what all this stuff means. And then go to the top and hit run. Now, even though it's a very simple instruction, there's a lot of stuff to learn here that'll help you learn programming. So here's the first thing. We'll start at the very end here. This semicolon tells the computer that everything before it is the complete instruction and we're done. There's no more instruction. You can move on to the next line. Now, we don't have a next line, but that's what the semicolon is. I just want to clarify that. But let's talk about this instruction called print. Python, like any programming language, comes with a bunch of built-in functionality that you can access. You can create your own functionality, but it comes with a bunch of built-in instructions, and one of them, of course, is called print. What's really interesting to see here is that the print is immediately followed by content that is inside of closed parentheses. You can see the content. We'll talk about the content in a moment. The content is just the words hi there. But I want to talk about those parentheses because they're actually kind of important. Here's the basic principle involved. Very often when you're writing a program and you're telling the program to do something, we call it a function. This print is a function. When you're telling the function print to do its job, that function needs some information before it can do its job. In this case, obviously, it needs the text content that you're going to print to the screen. And without that information, this print command can't do anything. So there's a phrase we use here. Here's the function. The function is called print. And here's the information that it needs. Let me highlight that. We are passing the information into the function. That's some of the terminology that's used here, right? And so the parentheses are there to say, hey, computer, I know you want to perform this print function, and I know that you need information in order to do that print function. I'm going to pass that information to you by putting it inside of parentheses. And we're going to come back to that. You're going to see that pattern later on when we're writing code. Another important thing to see is this. If you go to the print and hit space and try to run it, oh, it does handle it. It normally wouldn't. This is a very forgiving code editor. You should put the parentheses immediately following the function. This code editor handles the fact that you haven't done that, but you shouldn't be allowed to do it. All right, so I now want to take you through something that might seem very like laborious, like one step at a time, but there's actually some super valuable info here. Remember how I said computers are stupid? I wasn't just like, being silly for the sake of being silly. The fact is, computers can only do something if you've told them ahead of time exactly how to do it and how to behave. And I'm going to show you how the computer operates when we click run. When we click run, here's exactly what the computer does. Now, it does it very fast, but this is what it's doing. It goes to the beginning of this line, and it looks at the first character that I've highlighted, the letter P. And it checks to see whether or not that character is either a built-in instruction or the name of a variable. Now, we haven't made any variables at all. I haven't even talked to you about how to make variables. We don't have any variables in this program yet. But if you look at the letter P, the computer will check to see whether or not that's a built-in instruction in Python. And well, it happens not to be. There's no instruction in Python called P. And the computer says, oh, well, this letter P is not an instruction. It's not a variable. I can't do anything with it. I have to go on to the next letter. And now it looks at the PR and does the same thing. It says, is this combination of letters, PR, is that a built-in instruction in Python? And it's not. It says, is that combination of letters, PR, is that a variable? So the computer doesn't do anything. It goes on to the next. And same thing. It says PRI. Is that an instruction? No. Is that a variable? No. All right, let's go on to the next one. Same thing. It's not an instruction. It's not a variable. So it goes on. And now the computer says, is this an instruction? And it is. Because we've installed the programming language Python on our computer, the computer can go, oh, that is in fact a built-in instruction in Python, and I know what to do with that instruction. I've been told ahead of time what to do. Here's what I'm supposed to do. I'm supposed to look for information inside of parentheses and grab that information. And so this is what the computer does. It moves forward one character and says, is there a parentheses? Oh, good, there is. All right, let me move forward until I find the matching end parentheses. And so it moves forward, not a parentheses, not a parentheses, not a parentheses, not, oh, I found a matching end parentheses. Great. Well, now I'm going to go back to the first one, and I'm going to grab everything inside of here. And that's the information that's needed by the built-in function print. And I'm now have everything I need to do to run this print operation. Now, that took me like 5 minutes to go through and explain one tiny step at a time. When we run it, look at how fast it takes. It takes about a second, okay? But I do that illustration to show you how methodical and precise, and again, frankly, stupid computers are. They do things one step at a time. They can't do two things at once. They can only do one thing at a time. And they can only perform actions that have already been programmed into them. We programmed the print action in when we installed this language called Python on the computer. And that's the only reason the computer knows what to do. So the lesson here is that when you're writing programs, you have to try to think of every single thing that the computer program is supposed to do, and you have to provide exact instructions on what to do. The computer program can't figure out what you meant. So that's our first instruction. Let's move on and let's talk about variables. In Python, to make a variable, you just put the name of the variable. And variables have special names. I'm going to write this code out and then we'll explain it. So our context is Hangman. So we're going to put a variable called word. The word is what we're all trying to guess. In the example I showed, the word was programming. And do a space and then do an equal symbol. And we're actually going to do double quotes and we're going to use programming. And go to the end and do a semicolon. Now, let me explain what's happening here. There's actually two things occurring in this line of this instruction. And it's really valuable to know both of them. The first one is just what happens when we type the name of our variable. When the computer reads this, here's what it does. It says, I'm going to go into my memory storage area. You know those memory storage devices we're talking about. I'm going to go to the area in my computer where I can store data to be used by this program. And I'm going to choose one of those locations, and I'm going to give that location a name. The name of that location is Word. Probably the best way to think of this is that your memory storage devices are like millions of buckets. And each bucket can hold some information. But on the outside of that bucket, you're going to write down the name of the bucket. In our case, the name is word. So that's the first thing that's happening in this whole line of code. We are creating a memory location called word. We call that, here's the terminology, we call that declaring a variable. We've declared a variable called word. Now, let's look at this section of instruction. This is where you actually put information inside the bucket. To be a little more precise, we've reserved one of those memory locations and we've given it a name, word, right? And now we're going to store information in that location. What we're going to do is we're going to store the word programming inside that memory location. We call this operation, and I'm going to highlight it again. We call this operation where you put the information into the bucket. We call that assigning a value to the variable. So here we've declared a variable, and here we've assigned a value to that variable. Two things happening on the same line. So let's make use of this. Why don't we print what's in this variable to the screen? Do print in parentheses, and then type the name of your variable, W-O-R-D. Go to the end and do a semicolon. Let's run this. And it actually printed the value of the variable. Well, I told you that variables keep track of information that can change. Each time we play this game, there's a new word. Why don't we change the word? Go back over here, hit enter, and now let's change word to computer. Remember to type it exactly as I typed it. Now, I'm going to open up chat for a second. And I want you to drop into chat. What do you think is going to be printed on the right-hand side when we run this program? Don't run the program if you haven't already. What's going to be printed on the right-hand side? Good job, Alex. Okay. Almost everybody got it right. They said that programming is going to be there. Some people said computer. So go ahead and run it. And it is, in fact, programming. Let's talk about why. Remember that computers are stupid. They only do one thing at a time. And they do them in an exact order. So when I run this program, I do the first instruction. You can see that over here. I printed hi there. Then I do the second instruction where I create a variable called word and I give it a value of programming. I haven't printed it yet. Here on line 3, I print the value of that variable. At that exact moment in time, that variable still has a value of programming. We don't change it until after we've done the print. And the computer has no idea that's happened yet because it hasn't happened yet. The computer is doing these instructions in order. But we can get it to print the new value by using print again and printing word, just like we've talked about, we did before. And now it'll print the new value. So we've now used variables. We are creating data, in this case, the variable called word. We're keeping track of data that can change as your program runs. Remember the example I used before where you're talking about a computer game you're playing where you're keeping track of your score. Your score is going to change over and over and over again as you're playing the game. So that's what variables are all about. All right, give me just a moment. I've got to get some water because I'm talking a lot. All right, thanks for your patience. So we've covered, the entrance point. There's the first instruction, right? We've covered variables and we've used the variables. We actually changed the value of the variable and we were able to make use of that changed value when we printed it again. Now let's talk about control and branching. I'm going to introduce you to something new just to make this a little bit easier to understand here. I want you to type the pound symbol. It's above your number 3. And we're going to write control and branching in here. Now, this line of code I've just made isn't actually an instruction. It's called a comment. The little symbol, square, the hash or whatever. In Python, that is a special instruction that basically says, ignore everything else on this line. It is not an instruction. It's not to be performed. It's basically where you can leave little notes to yourself and to other programmers. So that's what this is. It's called a comment. Let's see if I can type. That wasn't even English. This is a comment. I'm just putting that there to help. So let's use some control and branching. Remember, the idea here is that we're going to force the computer program to choose between one of 2 or more available courses of action. We're going to force the computer to make a decision. Let's just pretend we're going to make something up here. Let's say that someone has guessed what the word is. And we need to see whether or not what they've guessed is the actual correct word. Let's all remember that at the point where we get to this part of our program, the value of our variable word is computer. So we want to say, hey, for a given guess, did someone guess the word correctly? That means we need a way to keep track of what they guessed. We need a variable. So let's make a variable called guess, and we'll make it equal to memory. That's a nice word. Now, we being human beings, we already know before we write any of this code, we know that the word the person guessed is not equal to the word they're trying to guess. We know that, but computers can't think. We have to tell them exactly what to do. And what we're going to tell them to do is to compare the values of the variable called guess and the variable called word and see if they're equal. If they are, we're going to print something on the screen that says, you got it. And if they aren't, we're going to say, sorry, try again. How do we do that in code? Well, we have to force the computer to make a decision. In this case, we're going to compare 2 values and see if they're equal, and then tell the computer what to do in each of those cases. Here's the language we use to do that. We use a special built-in instruction in Python called if, and do some parentheses. Now, we're going to move on. We're going to fill some stuff in the parentheses. I'm not going to show you that yet. I'm just showing you a kind of a structure here. Do a colon at the end of this line and hit enter. And you'll notice your cursor is now 2 spaces to the right. There's a reason for that. I'll explain that in a moment. And we're going to type in here, print, you got it. Go to the end, hit enter, and then back up to the beginning of the line and type else with a colon, hit enter. And this is in case they got it wrong. Print, sorry, try again. Now I'm going to give you all a moment to catch up. Make sure you type it exactly like I did. Make sure that the print lines are 2 spaces over. Take a sip of water. This pattern or structure you're seeing here is how we force the program to make a decision. There's only one thing missing. right inside these parentheses on my line 9, we have to give the computer something it can evaluate, something it can look at and determine whether or not it's true. In this case, we want the computer to look at the variable called word and the variable called guess and see if their values are equal. If they are, then we have a true condition. And if they aren't, we have a false condition. So here's how you do that. Right inside those parentheses, make sure your cursor is right where mine is. Type word, that's our first variable. Then type two equal signs, and then type guess. Let's go ahead and run this program. And you can all see that it says, sorry, try again. Probably that makes sense to you, right? Because the value of word is computer. The value of guess is memory. So inside these parentheses, we have a thing called a condition, and that condition is false. The value of word is not equal to the value of guess. But let's talk about a little more detail here. Let's look at this symbol right here that I've highlighted, these two equal symbols. This is a special instruction in Python, and it's called an operator instruction. Operators direct the computer to do a specific action. In this case, this operator directs the computer to compare the values on either side of the operator to see whether they are equal. There are lots of different operators. If we were dealing with numeric data, there are operators to say, is one number greater than the other? Are they equal? Is one number less than the other? There's lots of different operators, but you're just basically trying to tell the computer, hey, do a comparison on either side of this operator and tell me whether or not it's true. And in this case, we know it's not. Word is equal to computer, guess is equal to memory, they're not equal. So let's go down again. Make sure that you put your cursor back at the beginning. And I want to talk about the cursors and why they are the way they are. Here's another really important concept. Ignore the code for a second. Stop looking at the code and let's just talk for a second. When I was talking about the 5 fundamental elements of any computer program, and I talked about this control and branching, I said this, it's a way to make a computer choose between one of 2 or more possible courses of action. And so we have 2 different things here, the control instruction and the branches or courses of action. The control instructions here are if and else. The branches are the instructions right underneath each of them. But here's how you tell the computer, in Python at least, here's what to do in each of the courses of action. Here's what to do in each of the branches. You're only going to do one of them, but here's what to do in the case that you're going to do that course of action. And the way you do that is on the line right before the course of action, or we call them a branch. On the line right before the branch, you put a colon. And then any instructions underneath that line that ends with a colon, any instructions that are indented, that are shoved over by a couple of spaces, those instructions will only happen if the condition is true. Same with the else. Anything that is indented underneath that else will only happen if the condition up here is false. So these instructions, now we only have one in each branch. You could have 20, you could have 100. As long as they were all indented by two spaces, that's what to do only if the condition is true. And here's what to do only if the condition is false. And we call these branches, we also call them code blocks. It's a block or a collection of code. So let me look at the chat real quick and see if I've missed anything. All right, excellent question. Okay, so there's a question that came in about, let's go back to variables. Why does the value of the variable have to be in quotes? So we make a variable here. Let's look at line 2. It's my line 2, okay? It might be a different number for you, but let's look at line 2 where we create the variable called word the first time. Word is the variable, and it's going to store data. Now, there's lots of different types of data the computers work with. They work with, numbers and letters. They call it alphanumeric data. In other words, they work with words and sentences, right? That's one type of data, but they also work with numeric data. They work with date data, like February 14th, right? That's date data. And all these different types of data, they behave different ways. Number data behaves a lot differently than text data. You can't do mathematics with text data. You do mathematics with number data. Well, in a computer, in the language Python, most languages actually, text data needs to have quotes around it. That's what tells the computer that the data is text. If you don't have that, it doesn't know it's text data. So we could, for example, have another variable called score, and it would be equal to, say, 100. That's number data. Totally different variable. You can type that in if you want to. We're not going to use it, but there's a number variable. I hope that helps elaborate on that a little bit. That was a good question. Now, let's go back here, and let's just talk about something. In this little, chunk of code, I made up a situation. I made up a situation that someone guessed that the word was memory, but the word was actually computer. And we checked to see whether or not they got it right. And we told what to do if they got it right. And we told what to do if they got it wrong. Well, let's say a couple minutes later, they make another guess. Let's take the variable guess and we'll make it equal to computer. Don't run the code. I want you to write into chat what is going to be printed over on the right-hand side when we run this code. What's the last thing that would be printed when we run this code? Good job, Alex. That's correct. Jojo, I'll answer that question in a moment. I want more guesses. What's going to be the last thing printed when we run this code? Is he going to say, you got it, or sorry, try again? Most people got it correct. They said, sorry, try again. It's not going to say you got it. And let's talk about why. Go ahead and run it. It says, sorry, try again. That's the last thing that got printed. And the reason why is that we didn't change the value of the variable guess until after we had run this comparison. So at the time that we ran the comparison, the program didn't know. The program was like, well, word is equal to computer, and guess is equal to memory. Those aren't equal. So now we come to the next fun thing. We've looked at your first instruction. We've looked at variables. We've made a few different variables. And now we're going to look at a thing, and we look at control and branching. We've controlled which of two or more branches will be performed. But now we're going to look at subprograms. I want everybody to just take a look at the situation we have here. We have a situation right here where we set the word that was to be guessed to computer, and someone said, "Is it memory?" And we did a comparison and went, "No, you got it wrong." And they said, "Is it computer?" We have to do the comparison again. I don't know about you, but I don't want to write out these 4 lines again because they're identical. I have to do another comparison. I have to check whether or not they got the guess right, but I don't want to write this code out again. This is where the next of these 5 fundamental elements of a computer comes in. One of the most valuable, it's called a subprogram. It's a repeatable set of instructions. And let's create one, and then we'll explain it. It's really fun. Go down here, a couple of lines. The blank lines don't do anything except to make your code a little easier to read, by the way. Let's do a comment. Building a sub program. Remember, it's a comment. It's only there for us. The computer isn't going to do anything when it comes to that line. Maybe I should spell building correctly. We want a subprogram that does this comparison for us and does the control and branching. We want a subprogram that every single time someone makes a guess, we can say, "Hey, check to see whether they got it right." And if they did, tell them, "You got it." And if they didn't, tell them, "Sorry, try again." We want a program that will do that over and over again whenever we want. You do that in Python by using a special instruction called def. It means define. And hit a space. And now we're going to give a name for our subprogram. By the way, in Python, we call these subprograms functions. There's lots of different words for this same concept in lots of different programming languages. Sometimes it's subprogram, sometimes it's function or method or subroutine. They all are the same concept. I would like to build a repeatable set of instructions that I can call on anytime I want to in my program. So you need to give it a name. We're going to call this one compare. That's the function. It's called compare. And I'm actually going to make it a capital C. I like that. We're going to do a compare. That's the name of our function. We're making the function. We're defining what's going to happen. Now, in order for our function that we're building, the subprogram, right? In order for our function to do its job, it needs some information. It needs 2 different words that it can compare to see whether they're the same. So we're going to do parentheses immediately after the name of our function, and we're going to give 2 variables that the function is going to use. I'm going to call them word1, comma, word2. It's going to compare these 2 words and see whether they're equal. Go to the end of that line and hit a colon. Now, those of you who are paying attention when we used colons before, you probably realize what's going to happen when we hit enter. Our cursor goes over 2 spaces, and we are now going to lay out the exact instructions that will happen when we ask for this function to do its job. What are we going to do? We're going to do a comparison. We've done something similar before. We're going to say if word1 is equal to word2, and do a colon. And now that's a control instruction. Then we need a branch. So hit enter, and notice we're indented even more because now we're defining the branch. What's going to happen if these 2 words are equal? We're going to print the guess was correct. I like that. And now hit enter, but make sure you back up one notch. And we're going to do our what if the words aren't the same? We're going to do our else with a colon. And here we're going to print the guess was wrong. Try again. Hit enter and backspace all the way to the beginning. And that's our function. Again, let's talk about how this is going to work. Whenever we want to use this function, we have to give it two words. It will compare whether or not those words are equal. If they are, it'll print out the guess was correct. If they aren't, it'll print out the guess was wrong, try again. Now, this part's super important. Don't run the code. I'd like you to make a guess. When we run this code, what's going to be the last thing that's printed over on the right? Okay, so the correct answer is sorry, try again. I'm up here. The incorrect guess was the guess was wrong, try again. And let's talk about why. First of all, go ahead and run the code. This part's super important. In fact, we've gone over a lot of important data. This is amongst the top 2 or 3 most important things to learn. It can derail you whenever you're trying to learn any programming language. I'm going to ask you to pay close attention to this. We created a function called compare. And the important thing to know about creating a function is when you create it, all you're really saying is, I'm going to define some behavior or a set of instructions that could be performed in the future if and only if I ask them to be performed. That's all it means when you create this function called compare. You're saying, here's a set of instructions. I'm going to highlight them. Here's a set of instructions that later on in the program, if I want to do those instructions, I ask for them to be done. But I haven't asked for them to be done. In other words, when you create a function or a subprogram, you are creating potential work that could be done, potential behavior, but you have to explicitly ask for it to be done in your program. We haven't asked for it to be done. Let's ask for it to be done. The way you do that is simply by saying that, typing out the name of the function, compare, make sure you capitalize it because we capitalized it up here. And in parentheses, we're going to give it 2 words. Let's give it the words free and free. Those are 2 different words. They happen to be identical. So now when we run this program, it says the guess was correct because on my line 24, we actually called on this function. That's the terminology we use. We say we called the function. We said, hey, please run this function that I defined and do it with these 2 words. So now the computer goes, oh yeah, that function called compare. Let me go look at that. All right, compare. Well, I will have received 2 words. I received free, I'm going to call that word 1. And I received free, I'm going to call that word 2. And now I'm going to compare them. Oh, they're equal. All right, well, then I'm going to do this code block. I'm going to print the guess was correct. Watch this. Let's go down to the end again. Let's do compare. And we'll do free and frog. Run it, and guess is wrong. Here's the point I want to make. I was able to do a comparison with one line of code instead of four. Makes it a lot easier to write your program. Also, let's say we wanted to change the wording. Let's say I wanted to be more enthusiastic and I wanted an exclamation point after the guess was correct. If I do that inside my function, now every single time I use that function later on in the program, my changes are reflected. I don't have to change it in a bunch of different places. It gets changed once. So let's run this. And now I get my exclamation point here. That's the power of a subprogram or a subroutine. You're defining a set of behavior that you can call on over and over again later on. It does the exact same thing every single time, and you just give it the information that it needs at that exact moment. Let's do it using our variables from before. Let's change our variable word and our variable guess. Let's say that the word we're trying to guess is internet. And let's say, oh, sorry, I did it wrong. The word that everybody's trying to guess is internet, and our guess is web. So we just set up a pretend situation where our user of our game, he doesn't know it, but the word he's trying to guess is internet. And he said, is it web? Well, we need to compare them. So we can just use our built-in function that we made, compare, and we'll pass in word and guess. What we're really passing in is the values of the variable word and the variable guess. And because they're not equal, we should get the guess was wrong, try again. So this brings together almost everything we've talked about. We're using variables, we're using functions or subprograms, and that subprogram makes use of control statements like if and else, and branches, the sequence of actions that will happen based on the control instructions. So again, the parts of a program that you see on the screen, even in this very simple set of, very simple program we made, these are the only things you will ever find in any program, no matter how big or how small. There's lots of different examples for types of variables people can do. And there's lots of different ways to do control and branching. And you can make hundreds of subprograms, but it's all the same type of building blocks. And so if you become familiar with these 5 basic elements of any program, then you can start to understand any programming language or any program that you have to try to decipher. Now let's get back. I'll have your free gift for you momentarily, so please stick around. Let's do a little Q&A because I know there might have been things I missed here. Jojo asked a great question. I love this. Um, Aka, we'll look at your error in a moment. Okay. You should check to see whether or not your indentation matches mine. Let me go back to my code for a second. I love all these questions. All right, I'm taking one at a time. So Jojo asks, word 1 and word 2, are they just a local or temporary parameter? So let me go back to my code here for a second. Love that question. Okay. It's a really good one. So word one and word two, these are the names that the function, because remember, a subprogram, we call these functions in Python. The function, when it is given information, it needs to keep track of the information. So the function needs its own variables to keep track of the information it was given. Let's be a little more precise. Look down here on my line 28. It looks like we're passing in word and guess, but we're not really. We're passing in the value variable called word. In this case, we're passing in the internet. We're passing in the value of the variable called guess. In this case, the word web. That's what's being passed into the function we built called compare. So when compare is running, it takes that value, internet, and says, we're going to make a variable called word one, whose value is now internet. And we're going to take a variable called word two, whose value is now web. So these variables only apply to the function. They call that context. In the context of the function, we have variables word one and word two. Inside that function, the function has no idea about variables outside of it. It only has variables that it uses. I hope that explains that. That was a really good question. All right, another question was, why do you need a colon versus semicolon in some lines of code? First of all, the semicolon, I should be using it at the end of every single line of code that stands all by itself, but I'm lazy and Python is very forgiving. So like, for example, I didn't put a semicolon right here on my line 24 and it still works. I could put it there. Python is built to be very forgiving in that regard, okay? Now, as to the colons have a very specific purpose. What a colon does is it says, listen, I'm about to, on the following lines, create a code block. I'm about to create a section or a collection of instructions that will only be performed in a specific situation. The instructions that follow, as long as they are indented, are to be treated separately. They are their own thing. So for example, we could have multiples here. We could say if the words match, we could first print the guess was correct, and then we could print you win a gold star. And then we could print play again. And notice this, you put a question mark there. Because all of these instructions are indented relative to the line above them, they are treated as a collection, separate from other lines of code. They call it a code block. And these instructions, again, will only be performed if this condition is true. So the colon is what tells Python, look at the following lines and find all of the ones that are indented and treat them separately. Without that colon, Python doesn't know to do that. I hope that helps. Let's see if there's another question. Awesome. Now let's look at Hangman. Yeah. Alex said the events description said we're programming JavaScript. That may completely be my fault. I apologize. It was a Python. We JavaScript and Python back and forth on different classes. But I will tell you this. The fundamentals, those 5 basic elements of any computer program, those are the same no matter what we teach. They're the same no matter what language you're learning. Those are the ways to start learning the program. All right, now, let's go ahead and get you the code. Let's see if I can find it. Here it is. Awesome. So if we open up that link, and copy all of the code, and then go back to your code editor, select everything and erase it, and paste in the code. Jojo, it's a good question. I don't know if we have the time to dive into that. All right. So once you pasted it in, you can run it. And I want you to take a moment and play a game of Hangman. And then we'll move on. I'm going to try it again. Let's see, R. Ooh, I got R. O. N. I got programming again. I got it right. Let's play it again. No, no, T. S. A. E. Oh, man. I'm going to die here. N. O. G. I. Ah, it's coding. Okay, I got it. Okay. So now, everybody stop for a moment. And we're not going to go through this entire program. This is 130 lines of code. But I just want to show you that most of the things in here, you can start to at least recognize some of these building blocks, these 5 fundamental elements. First, we're defining a bunch of functions. By the way, this import means we're bringing in a bunch of pre-built code that can generate random numbers. That's what that means. But look, we made a function called choose word. We made a function called display hangman. We made a function called play. A function called main. So you see a bunch of functions. And inside them, we see variables. Here's a variable called words. And it looks like it's a collection of words. Okay. And it looks like we were going to choose one of those words at random. Like, even though you don't know the exact syntax, the exact rules of Python 100%, you can read through this and kind of figure out what's going on. We're going to pick one of those words at random. I like that. And we have a variable called stages. And it looks like it's just, what does it look like as you get more and more guesses wrong? Okay. And then we have a variable called word completion. Well, there's a couple things you might have to look up there, but you can see we've got print statements. Look, we've got if, control and branching. So you could start to read through this and you could guess a lot of the logic involved, especially as you were playing it. Okay. So again, beyond the scope of our class to go through every single bit of this, although I can tell you, any one of our graduates could build a program like this completely from beginning to end, and much more complex programs. Let's go here. Okay. So I mentioned that we provide boot camps. Well, we provide a lot of boot camps. In fact, if you look here, you'll see certification boot camps we have for all sorts of subjects, including artificial intelligence, mobile app development, obviously Python, right? JavaScript, data science, user interface, front end mobile like game developer. In fact, we have more boot camps than any other boot camp provider on the planet. I'm pretty proud of that. But it's how these boot camps are run that I really want to cover with you. They're self-paced, which is a huge deal. You can learn at your own pace instead of having to move in lockstep with everybody else. Okay. Every single one of them covers in-demand skills that hiring managers want right now. They're all fully online. They're flexible, so you can set your own start date and your own schedule. So you can fit your boot camp in around a job or going to school. And every single one of them comes with job placement training and the job placement support to help you, in your job search. And they're all certified by the Higher Education Commission. Um, we have an average of, I think, well, I've got information on it here. We receive almost every top coding bootcamp award there is. In fact, about a month ago, Newsweek put out its list of the top 31 boot camps in the world, and we were in that list of the top 31 boot camps, which we're very proud of. Our average review rating across all the bootcamp review sites out there is 4.8 out of 5 stars. And these are reviews from our students and graduates, people that are in the best position to say their opinion about who and what we are and how well we helped them. Okay. So this might bring up the question about why consider working in tech. Now, I know it's Friday night and y'all like took the time to go through a coding class. There's probably at least some interest. I can tell you this: technology as a career has really good work-life balance. Remote work possibilities are there. It's a good career to work in. It's also a very creative field where you can take a lot of personal pride in the work that you do. And it pays well, which isn't a bad thing. And if you keep on applying yourself and learning more and more, then pay raises come with it, and you can end up making a lot of money in the technology field. Not that it's all about money, but it helps the other areas of your life do really well. Okay. Now, with all that said, there are barriers to entry to doing a boot camp. There's only three ways to break into technology: college or university, self teaching, or a boot camp. We know boot camps really, really well. And there are some barriers, including the money. It can take thousands of dollars to do a boot camp, tuition. We've done everything we can to make that as confrontable and affordable as possible, including a massive discount if you pay, the full amount upfront. Or if you need to like spread it over time, we have phenomenal financing options for anybody in almost any like financial situation. One of the other barriers is the sheer time involved. There's a lot to learn in a tight period of time. Some schools try to solve that by making you train as a cohort. Everybody starts on the same day. They all move through the material at the same pace, and it's really rough. If you fall behind by a day, you're lost. Our programs are self-paced, so you don't have to worry about that. Also, some schools require you to go on campus and study in person. Our programs are fully online. You can do them anywhere in the world. Finally, in terms of barriers to entry, you do have to at least have some technical interest and some technical aptitude. But I will tell you this: if you've ever felt like maybe you're not smart enough to do technology, or like it's too complex or above you, I assure you that's a problem of the material, not of you. Very often, technology instructors assume too much prior knowledge on the part of the student. With our programs, we don't do that. Anybody can get through our programs. No prior technology or coding experience is required. So I've got a question for you. Are you perhaps working a dead end job? Maybe a job that you're okay with it, but when you look to the future, 5 or 10 years down the line, the pay ceiling is not where you want it to be, or you don't have the right work life balance. Maybe you want to spend more time with loved ones. They want to work remote, and you work in a career where they'd never allow you to work remote. The big question is it time for a change? And if it is, I'd like to put forth the idea that the Tech Academy is the solution. We are career change experts. At this point, we have more than a decade of experience in helping people change their career and break into technology. And they do really well. On average, our graduates make $30 an hour, which is $60,000 a year in their first job. And we have thousands of graduates working at all kinds of companies, from small little mom and pop, companies, to medium-sized businesses, to the big companies like Nike and Epic and Uber and yeah, everywhere in between, right? So, and Disney, we have people working at Disney. So this is what we do. And at this point, like, if it's something that makes any kind of sense for you, you really should just at least find out a bit more about who and what we do. I will say, if in the month of February you decide to enroll, there's some massive enrollment gifts that are available for you. First of all, if you can pay up front, you get a full 50% off the tuition. It's a really big discount. And if you are in America and you need a laptop to do your training, if you pay the full tuition up front, we'll send you a laptop that you can keep to do your training. Also, if you sign up in February, there's no sales tax. It gets paid, but we pay it for you. which, depending upon the state you're in, can be a really big deal. Okay. You'll also get your own set of our coding books and our dictionary, physical books sent to your house that will help you get through your studies. We've written 3 coding books and a computer basics dictionary that covers, in simple terms, all the complex technology, words that you've probably heard, right? Also, you'll get a free copy of our career planning guide. And this doesn't exist anywhere else. This is essentially myself and my co founder sitting down and writing what would be the perfect guidance to give someone to navigate the first 3 years of their technology career. What do you do for the first 6 months, 18 months, 36 months to set yourself up with a really solid foundation for a long term successful career? We laid everything out in this career planning guide, and we'll send you your own physical copy. Also, if you sign up in February, you get 3 months of free access to what's called the Tech Academy Accelerator. Now, I love this. I get to deliver this every week. It's a very low cost subscription that gives you access to to weekly workshops delivered by me that are super deep dives, open voice, open chat, open video, where we build things and break things and get our hands dirty to really help accelerate your career really quickly. There's also access to over 100 free educational videos and courses that you get, along with all past workshops, and we've delivered them for over a year now. When you join the accelerator, and you get 3 free months of access to that. And finally, this is huge, unlimited job placement assistance. We have specialists on staff that their sole job is to help people get hired in this industry, and they will work with you for as long as it takes for you to get your first job. And that's hard for us to do because we're just obligating ourselves to be with you as long as it takes. But if you sign up in February, that's part of what you'll get. So, how do you find out more? You go to this link. Grace is going to drop this into chat. And if you fill out a simple form, and then you'll get access to all kinds of information about us. How do we teach? What are the courses? What order do the courses come in, and why are they in that order? How do I study? How do I set up study schedules? What is that like? All your questions get answered. Okay. We want you to know everything about the program before you make a decision. And this is where you find out. So I'll give people a moment to click on that link. We got your free gift in a moment here. Just sit tight. I also want to tell you about a referral program. Since our graduates and our students love us, for years, referrals has been one of the top enrollment sources for the school. And so years ago, we put in place a referral payment program, which is not restricted to students and graduates. You can do this too. If you recommend someone to us and they end up looking at the school and signing up, when they pay their tuition, we will send you a check for 5% of what they paid. We love to do this. It makes us very happy to pay those checks because, frankly, you're changing somebody's life if you refer them to the school and they end up like getting through a boot camp and breaking into the technology industry. So in a moment, you'll have an email that you can address. You can send stuff into us to get your free gift, and you can include any referrals you have in there. We keep track of them. We've also published 6 books in a dictionary, including 3 Learn Coding books, a technology basics dictionary, project management book, and You Are Not Stupid: Computers and Technology Simplified, which is essentially like the book everyone on the planet should read to clear up any bit of mystery there is about computers and technology. It was the work of, well, honestly, I've been putting work together into this, me and my co-founder, for years. It's a phenomenal book. So here's your free gift. It is, in fact, Learn Coding Basics in Hours with Python. If you want to do a much deeper dive into the Python language and learn even more about how those 5 fundamental aspects of any program work, this is the book you want. And we can send a physical copy to your house. Be happy to do so, right? So you see that email address right there. Gracie's dropped that into chat. Just send us an email saying, hey, I was on the free class with Eric. He said we can get this Python book. Here's my mailing address. Please include your mailing address or we can't send it to you. And also, I'm sorry if you're outside the US, we can only send this to people in the US. If you want to read the whole thing, though, I think you can get it for a couple of bucks on Amazon. I think the Kindle of it is like $2, right? But you can also, of course, always order a physical copy and they'll send it out to you. But if you're in America and you want a copy of this, we will send you a physical copy to your house. It's a great book. I'll leave that there for a minute for people who want to send that email in. So I want to give you the link for our link tree. If you're not familiar with that, it's just it's a little quick website where all the links for a business or a person can be listed. Here's where you're going to find links to everything about us, all of our social media, our free YouTube educational video channel, links to our next meetups, like all of our meetups, so you can find out when the next classes are. Everything's on there. So this one place is where you find all things about the Tech Academy. So follow us on social media. Please come to our next classes. We'd love to have you, right? And I just want to tell you, thank you so much for taking a Friday night and doing this. Appreciate you being patient with me, being 5 minutes late. That's very kind of you. Um, and I hope that there's any interest at all in breaking into tech, that you just take the time to find out who and what we are, because we're very good at what we do and helping people break into tech. We're super passionate about it. So you can go to that link that you see right there, fill out the quick form, and find out everything you need to know about the school. I'm going to stop sharing right now. Check out the chat and see if there's anything else. Awesome. Thank you, Jojo. Appreciate it. All right. Totally fair question. See if I can ask this or answer this real quick. Ah, he asked about how line 78 works. We take this symbol, which is an underscore. We calculate the length of this variable called word. Let's say the word is robot. So we know the length is 5. And we take that number 5 and we multiply it times this underscore. And so we have 5 underscores. You can see that when we play the game. Here's the underscores. This is probably about 7 or 8 underscores. Whatever the length of the word is, that's how many underscore symbols you get. I hope that answers that question. That was a good question. Check chat again. All right, good. Thank you all so much. Super appreciate it. Alex says for the free book, we need to provide our name and mailing address. Yeah, exactly. Yeah, we'll send the physical book out to you. We won't do anything else with your address. We're not going to send you anything else. We just want to be able to send you the physical book. All right. Thanks all. Appreciate it. Have a good evening, and we will see you in future classes. Bye.